I can write a function given a description of the situation it represents. Here's what you need to know. Real-world situations can be represented as functions. Depending on the information that's given to you, one form might be easier to write. So we've learned about slope-intercept form. That's where our output is equal to our slope times our input plus our intercept. The slope is a value that's being multiplied with our input, and in real-world situations, your slope might be the price per item or the speed per hour and so on. Anytime you have some sort of multiplication relationship, that's the majority of the time going to be your slope. And your y-intercept does not depend on your input value. This b right here stands by itself. It's not touching your input at all. It doesn't care what your input is. In real-world situations, that means that your intercept might be a one-time fee or your starting amount, something like that that does not depend on anything else changing. It's something that remains constant. Another form that we can look at is standard form. So that's where we have something times our variable x plus something times our variable y equal to a constant value. And in this form, each variable represents something that we don't know. In real-world situations, your coefficients are the values that are directly related to each variable. Your constant does not depend on any variables because it stands by itself. So in real-world situations, your constant is oftentimes your total amount, or something that is just, it's a number by itself. You're not multiplying it or dividing it with anything else. Let's do an example. A soda company buys 400 ounces of syrup to use for sweetening their sodas. The large soda bottles require 16 ounces of syrup, and the small soda bottles require 4 ounces of syrup. Write a function to represent this situation. Here are some steps to help you write a function. The first thing that we're always going to do is identify what we don't know. What are the variables? Then we're going to use the rest of the information in the problem to figure out which values are associated with our variables and if there are any values that don't depend on our variables. And then finally, we use those pieces to write our equation. So let's start by identifying what we don't know. We do not know the number of large bottles of soda, so let's let that be x. We also don't know the number of small bottles of soda, so let's let that be y. Let's gather which values are associated with our variables. I know that I need 16 ounces for each large bottle and 4 ounces for each small bottle, and I know that the total is going to be 400 ounces. That means I'm going to take 16 times my number of large bottles and 4 times my number of small bottles to total up 400 ounces of the syrup. There we go. That's my function right here that goes with this real-world equation. Pause and try this one. Cale read 50 pages of his book each day until he finished the book. His book was 300 pages long. Write a function to represent the number of pages Cale has left each day. Start by identifying your variables. Let's let x stand for the number of days that are going by. And so my function is going to be the number of pages that he has left to read after those days have passed. Let's find the values that are attached to our variables. I know that my starting number of pages is 300, and then I'm going to be reading 50 pages per day. I'm going to be subtracting 50 pages off of my total every single time that a day passes. We will be decreasing the total pages remaining after each day passes. That means that my function is going to be 300, my starting place, minus 50 pages per or times the number of days. You could also rearrange this and put this orange piece in front of the 300 to make it look a little bit more like slope-intercept form. The order over here does not matter as long as the sign is being carried with your term. We know that this 50 has to be negative because he's decreasing by 50 pages per day. I can sketch the graph of a linear function and find its intercepts given a description of the situation it represents. Here's what you need to know. To graph a function or to find its intercepts given the description of the situation, it's helpful to just write the function first instead of jumping straight to a graph. A graph just requires you to find any 2 points and then you connect them with a straight line. Remember that 2 points that are super easy are your intercepts. Just go find your x-intercept and your y-intercept. To find your x-intercept, you evaluate the function where y equals 0, where the output is equal to 0. And to find your y-intercept, you plug in x equals 0. Remember that f of x and y are the exact same thing. They both represent your output. It's just a different way of writing the same thing. Here's an example. Same example as before with the soda company, but this time we're going to be graphing the function and finding our intercepts of the function. Remember that the graph only requires us to find 2 points that are going to be in this equation, and I'm going to use the intercepts because they're easy to do. We already know that this is what our function looks like from the previous example. So let's try plugging in some zeros to find our intercepts. That's going to give us some points that we can use on our graph. When I plug in y equals 0 and use my order of operations to solve, I get that x is equal to 25. When I find my y-intercept by letting x equal 0, I use my order of operations to find that y equals 100. So I'm going to use those 2 points on a graph. Here's the point 25, 0 and the point 0, 100 and connect them with a straight line. So my intercepts tell us that the company could use exactly 100 small bottles and none or 0 of the large bottles, or they could use different combinations of large and small. Or we can come down here to this intercept and use 25 large bottles, but then we could use none of the small bottles because we wouldn't have any syrup left over. If we fill up all 25 large bottles, that's going to be exactly 400 ounces of syrup, and I don't have any left over to fill up any of my small bottles. So your intercepts can actually tell you a lot about what's going on in the problem as well. Pause and try this one. Cale read 50 pages of his book each day. We are going to be graphing and finding the intercepts of this function. So we already know that our function looks like this. Let's do our intercept. So hopefully you found that the x-intercept is at this point 6, 0, and that your y-intercept is at this point 0, 300. That makes the graph look a little like this. Our intercepts are telling us that on day 0, so when he started, he had 300 pages left to read. That makes sense. If you haven't read any of it yet, no time has passed, you got the whole book left. On day 6, down here where I'm pointing, he has 0 pages left to read. So that means he finishes the book on day 6. If you want more on this topic, be sure to check out the Learning Target spreadsheet for additional resources, videos, and practice.